now we're going to use tangent lines to estimate locations on a curve. So it's a weird kind of hypothetical, but like say we know that point. I can find the equation of the tangent line, which would be like the surfboard at that point, right? And then I can use that. So in this imaginary scenario, I know this point, but I don't know this one. So I can use the line to estimate. In reality, everything's like way close together, so it doesn't look like it's a bad of an estimate as it looks here. But we're assuming, like, okay, this does curve up, but let's just pretend it went straight and use, like, that point to try to estimate what the actual value of the curve is out there. So we get into this concave up and concave down. So concave up makes a U. Right? Because U is the first letter of up. And if the graph is curving up like this, and we use a line to estimate it, are we going to undershoot or overshoot our target? We're going to go underneath, like literally we're going to go underneath our target, right? Because the graph will curve up, but we're just saying, no, we're just going to pretend it's straight. So if it's concave up, the line, the tangent line, will underestimate. What? I didn't even think about this before, but up starts with a U, underestimate starts with a U, and the graph looks like a U. This is crazy. So calculate down is the opposite. I'll try to explain again though in case that estimate thing doesn't make sense. So we're saying like I know that point, I know the slope of that point, so I can make like a tangent line here. And I can what I really want to know is the Y value here. But I don't know that. So I'm going to use the line to estimate it by saying, well, I know the line has a value of this. So that's pretty close. It's not perfect, but it's pretty close. But if it's concave down, now it's curving down. So down, if you think of like a lowercase n, that's what it looks like. And now is my line going to go over the top or underneath where we're going? Now we're going over the top, right? So now this is an overestimate. So you got to know how to do the problems I'm going to show you, and then tell me if the problem. And these aren't bad. Can I erase that stuff? We'll look at first problem here. So when you see local linear approximation this here, that means the tangent. So we're going to locally pretend it's a line instead of a curve. So in that little area, we're going to pretend it's going straight, even though it curves up, and we're going to use that line to estimate it. I know it's not accurate, but we're going to estimate it. So they're going to give you this to find the tangent line. And then our tangent line is based on x equals 4. And then we're going to use that tangent line to estimate the value of the function when that is 348. So x is 4, y is 5, I've got a slope. Will this value be bigger or smaller than 5? So it's not. You want to explain why? Yeah. So the slope at 4 is positive. So when I'm at x equals 4, I'm going up, right? Well, 3.8 is backwards. Should be lower than that. Just like a way to kind of think about it, if your answer makes sense or not. So let's find the equation of the tangent line. So y equals blank times x minus blank plus blank, and we don't have to take any derivatives, which is pretty nice. This one they just give it to us. So you should know where these things get plugged into. So this is your x, y, so we got 4, 5, and then this derivative at x, so the derivative at 4 is 3. So that's my tangent line. And I wouldn't, like a lot of times they'll say put it in y or something. I don't really ever ask for that. But I would not do that here because because your next job is to take that equation and use it to find out what 3.8 would be. So it's easier, because if you had worked it all out, you end up doing like 3 times 3.8, which nobody knows. But this you can do a little faster. So what's 3.8 minus 0.4? Negative 0.2 times 3 is negative 0.6. So I get 4. We said it should be a little bit smaller than 5. 4. It doesn't guarantee it right, but at least it like kind of checks that I don't have an unreasonable answer. Find the equation of the tangent line, plug in the point they gave you, and then is this an overestimate or an underestimate? It's concave up. So when we draw a line underneath the concave up, it doesn't matter if you do it over here, at the bottom, whatever, you're going to be going underneath that curve. Question on one? The two is the same thing, it's just they're making you do a little more work. I can still find the equation of the tangent line, so y equals blank, times x minus blank, plus blank. A lot of times they won't ask you part A, they'll just skip to part B. They're trying to kind of guide you through it here. Part A, hey, find the tangent line. But they're also likely to just say, what is the estimate? You kind of skip this part, and you're supposed to know that's going to be the tangent. So remember this local linearity thing, local linear approximation, that's tangent. So x is 1, so x goes here. What goes here is f of 1. What goes there is f prime of 1. F of 1 would be 5, I can't tell, is that plus or minus? It's a minus, so 5 minus 2 is 3, 3 minus 2, so that would be 1. And then what goes here is f prime of 1. So your derivative, 5 minus 6x squared. What am I going to plug in? 1 or 1.1? We plug in 1. My first job is to find the tangent line at 1. F prime of 1 is 5 minus 6 times. It's a lot of work for 5 minus 6. So it's negative 1. So that's the equation of your tangent line. Agree there? My next job is to, okay, I know that's a curve, but I don't know the value of that curve when it's 1.1. I can find the value of the line, and I know those are close, so I'm going to do that. Again, I wouldn't distribute, because I think when you subtract the numbers in the parentheses, you're always going to get a small number, 0.1, 0.2, negative 0.1, negative 0.2. So let's subtract those, that's 0.1. Negative 1 times that is negative 0.1. Negative 0.1 plus 1 is 0.9. Is that an over or underestimate? Overestimate why? Because it tells us concave down. So this is an overestimate. And there's no like long explanation required. You don't have to explain like the line goes over the top or whatever. You just gotta say because it's concave down. You just gotta say because it's concave down. Okay, for 2. Alright, 3. Just a little different scenario, same questions, but just kind of a little different setup. So I'm going to find the equation of the tangent line. They were nice enough to give me the 0.20, so I can just right away throw in 2, 0. And then my job is to plug in the derivative of the slope. Do I have to take the derivative mistake I'll see is people will take the derivative of that. But we just need to get to the derivative of it. If you're at the original, yeah, take the derivative. But we're already at the derivative. So I need to find what happens when I plug in the point. So the derivative would be e to the 0 times 2 times 2 squared minus 5 times 2. So I'm just plugging in 2 for x and 0 for y. E to the 0 is 1, so that doesn't matter. That's 8 minus 2. 8 minus 10, so negative 2. So that's the equation of your tangent line. Good there? Now what do I plug in? 2.2. Plus 0, right? So 2.2 minus 2 is 0.2 times negative 2 would be negative 20. Questions? I think this is too bad. Alright, you guys got the section to do? Let me look at the app and see where we're. So I don't care about 9, but I do want you to do 10. So let's skip 9.